We're going to look at one more of these problems where we're finding extreme values subject to a constraint. So let's look at this following example. Find the extreme values of the function. We're going to go back to a function of just two variables. Subject to the constraint x squared plus y squared is less than or equal to 10. Now, if you look at your constraint, it's not actually an equation. Our constraint is an inequality. So here you're going to have to break the constraint into two cases. So the first case will be where it's equal to, and if it's equal to, then you're looking at a circle. So on the circle, x squared plus y squared equals 10. And what you're going to do here is you're going to use Lagrange multipliers because I have an equal to. I can use my method of Lagrange multipliers now. So the gradient of f, go back up to your function f, the partial derivative with respect to x would be 2x minus 2. The partial derivative with respect to y would be 4y. And then take lambda times the gradient of g. So you get 2x, so it'll be 2 lambda xi. And then 2y, 2 lambda y, j. And now we're going to write down our system of equations. We're going to set the I components equal. Set the j components equal. And then our constraint equation, which is x squared plus y squared equals 10. So here's our system of equations now. So we're going to take the last equation, the second equation. If we take this second one, and I move all my terms over. Well, let me divide by 2 first. So you'll get 2y equals lambda y. Move all your terms over to one side. And if you factor out a y, so either y is 0 or lambda is equal to 2. So if you plug in y equals 0 into your constraint equation, we'll say if y equals 0, then we're looking at x squared equals 10, which means x equals plus or minus square root of 10. So I get 2 points, square root of 10 comma 0, y 0, and negative square root of 10, 0. If lambda is 2, then go back to your first equation in your system of equations. So you have 2x minus 2 equals 4x. Negative 2 equals 2x, so x is negative 1. And if you plug in x equals negative 1 into your last equation, you'll get y squared is 9, y is plus or minus 3. So I'm getting the points -1, 3, and -1, -3. So I get 4 points here, these 4 points, and I need to plug all 4 of these points into my function f and compare the values. So if I plug in square root of 10 into f, you'll get 10 minus 2 square roots of 10 plus 3. This is approximately 6.675. If I plug in negative square root of 10, 10 plus 2 square roots of 10 plus 3, this is approximately 19.325. And then plug in your 2 other points, -1, 3, and -1, -3. So if you plug in these into f, you'll get 1 plus 18 plus 2 plus 3, you'll get 24. And you'll get the same thing if you plug in -1, -3. So if we're looking for which ones of these are the largest, 24 is the largest. There's my maximum. And this one gives me my minimum. Now, this is just really the first part of the problem. Now we got to look at the inside of the circle. Remember I said we had to break it into 2 parts inside the circle. So that's where x squared plus y squared is less than 10. And here, you're going to have to use critical points and your second partials test to determine if you have any relative extrema. So go back to your function f and write down your partial derivatives. We have these from earlier. And you want to set them equal to 0 and solve them simultaneously. You'll get x equals 1, y equals 0. So you're looking at the point 1, 0. That is inside of that circle of radius 10. So now I need to do my second partials test. So compute fx, x, it's 2, fyy, which is 4, and then fxy, which is 0. So d, no matter what point you plug in for d, you get, remember that d comes from fxx, fyy, minus fxy squared. D is always 8, which is bigger than 0. And if you look at fxx, it's 2, which is positive, which means you have a relative minimum at your critical point, 1, 0. So you need to plug this into your function, f of 1, 0. 1 minus 2 plus 3 is 2. So now you're going to compare the values you got in the first part and the second part. So I'll say essentially what we're doing is you're combining results from both parts. You'll see that f has a maximum. What was the largest value I got? It was 24, and it occurred twice at the points -1, +3, and then -3. So I'll just write them -1 plus or minus 3. And then the smallest value f has a minimum of 2 that occurred at the point 1, 0. So there's my maximum and minimum values of my function on the boundary and inside of the circle of radius square root of 10.